Good day, everyone. For today, we are going to have another topic in general mathematics, which is evaluation of functions. Here are the learning objectives. 1. Evaluate a function. And 2. Solve problems involving functions. But before we start our discussion, are you familiar with our traditional Filipino song, LERON, LERON, SINTA? To understand the concept of evaluation, we will sing the original song and change the lyrics of the song.
First, let us sing Leron Leron Sinta using its original lyrics. Leron Leron Sinta, buko ng papaya, dala-dalay buslo, sisidla ng bunga, pagdating sa dulo, nabali ang sanga, tapos kapalaran, humanap ng iba. Now, let us sing the song once again, but this time, let us replace all of the vowels with the letter A. Laran, laran santa, baka ng papaya, dala-dalay basla, sasadla ng banga, pagdatang sa dala, nabala ang sanga, tapas kapalaran, hamanap ng aba. This time, let us change the vowels to letter E. Leren, leren sente, bekeneng pepeye, dele, dele besle, sesedle neng benge, pegdating se dele, nebele eng senge, kepes kepeleren, emenep neng ebe. We're halfway through this. Now, we're going to sing this by replacing all of the vowels with letter I. Lirin, lirin sinti, bikining pipiyi, dili, dili bisli, sisidlining bingi, nigditing si dili, nibiliing singi, kipis kipilirin, iminip ning ibi. Now, let us sing this song once more, but this time, let us change the vowels into letter O. Loron, loron santo, boko ng popoyo, dolo, doloy buslo, sasadlo ng bongo, pagdotong sa dolo, nobolo ang songo, kapos kapaloron, hamanap ng aba. Finally, let us change all of the vowels with the last one, which is the letter U. Lurun, lurun sunto, pupunong pupuyo, dulo, duloy buslo, susudlo ng bungo, pagdutong sudulo, nubuluong sungo, kupus kupuluron, umunop ng ubo.
Thank you, Jerlyn Shane Diego, for singing that song. Relating the song to the topic of evaluating a function. When we say evaluation, it means to replace every x in the function rule f of x with a given replacement value, then simplify the resulting expression. Just like what we did on the lyrics of the song, we replace all the vowels first by letter A, then E, then I, O, and lastly by U. Applying that concept, when a function f is defined by y is equal to f of x, then x is called the independent variable. Any element of the domain can be chosen as a value of the independent variable. We call that one as the domain, but here we call it as the independent variable. And the resulting value determines the corresponding value of the dependent variable y. So dependent variable here is the range. Do you remember the concept of function as a machine? We have here the input, which is 2. We put it inside and process it using this rule to get the output, which is negative 9. Here, in the equation f of x is equal to 2x minus 5, x here is your independent variable. And the value of that independent variable is negative 2. And then when we substitute it here, we will have negative 2 times 2 minus 5. We come out with the value of y, which is negative 9. That f of x is your dependent variable or your y, since we know that y is a function of x. Let's have some illustrative example. If f of x is equal to 6x squared plus 2x minus 5, find f of negative 3. So again, all we have to do is to substitute negative 3 to all the x's in the function. So we will have here f of negative 3 will be equal to 6 times negative 3 squared plus 2 times negative 3 minus 5. Simplifying it, we will have negative 3 squared is 9. And then we will have 2 times negative 3 is negative 6 minus 5. Simplifying further, we will have 54 minus 6 minus 5. So our value will be 43. If x is negative 3, y is equal to 43, or f of negative 3 is equal to 43. Let's have example number 2. If f of x is equal to the square root of x squared plus 3x plus 2, find f of 2. So again, replace all the x's by positive 2. So we will have f of 2 is equal to the square root of 2 squared plus 3 times 2 plus 2. 2 squared is 4 and 3 times 2 is 6. So we will have the square root of 4 plus 6 plus 2. That will be equal to the square root of 12. Simplifying square root of 12, we can have the factors square root of 4 times 3. So your final answer will be square root of 4 is 2, and then we copy square root of 3. So we have f of 2 is equal to 2 square root of 3. Let's have example number 3. If f of x is equal to 2x squared minus 5, find f of a plus b. So here we have the expression a plus b. Applying the concept still, meaning we replace x here by the quantity a plus b. So we will have f of a plus b will be equal to the function 2x squared minus 5. So replacing x by a plus b, so we'll have 2 times the quantity a plus b squared minus 5. Applying the rule for square of a binomial. So the square of a binomial is the square of the first term plus the product, twice the product of the two terms, and the square of the last term. So that will give us a squared plus 2ab plus b squared times 2 minus 5. And then we multiply 2 to each term here. That will give us 2 times a squared is 2a squared. 2 times 2ab is 4ab. And 2 times b squared is 2b squared minus 5. We can combine similar terms here, but since there are no similar terms, so our final answer is as is. So that will be f of a plus b is equal to 2a squared plus 4ab plus 2b squared minus 5. Let's have example 4. If f of x is equal to x plus 1 for x greater than 0 but less than or equal to 10, and then 3x minus 2 if x is greater than 10 but less than or equal to 20. And then we have x squared plus x minus 1 if x is greater than 20. So find f of negative 1, f of 14, and f of 31. So for number 1, we have f of negative 1. Since the value of x is negative 1, and that belongs to the first equation. So x greater than 0 but less than or equal to 10. So we will be using the first equation, which is x plus 1. So we'll have f of negative 1 using the first equation x plus 1, so that will give us negative 1 plus 1. So that will give you f of negative 1 is equal to 0. For number 2, f of 14, so 14 here belongs to equation 2, greater than 10 but less than or equal to 20. So we'll be using the second equation, 3x minus 2. Again, replace x by 14, we will have f of 14 is equal to 3 times 14 minus 2. 3 times 14 is 42 minus 2, that will give us f of 14 is equal to 40. And for the last example given, we have f of 31. 31 belongs to the third equation. We will have for greater than 20. So we'll have x squared plus x minus 1, replacing again x, all the x here by 31. So we will have 31 squared plus 31 minus 1. And 31 times 31 or 31 squared is 961 plus 31 minus 1. So we simplify that one, that will give you 991, or f of 31 is equal to 991. Is that clear? Let's have application problem number 1. The number of hours until a cell phone's battery goes from fully charged to empty is represented by the function f of x is equal to 100 minus 10x. What percentage will the cell phone's battery be after 3 hours? Okay, here, your function is f of x is equal to 100 minus 10x. X here refers to the number of hours, that is your independent variable, the number of hours. And f of x here, or y, is the percentage of the cell phone's battery after being charged. So we are looking for 3 hours. So that means we only have to find f of 3. So substitute that one to the function. So replace x by 3, that will give us 100 minus 10 times 3, that will be equal to 30, and 100 minus 30 is 70. To answer the question in the problem, so we will have the cell phone's battery is 70% charged after 3 hours. It is important that you have the conclusion to answer the problem, since this is problem solving. Let's have another example. The function c of x is equal to 18x plus 170 represents the daily expenses of a food stall in a school, where x is the number of tapsilog meals the food stall prepares. How much will the food stall's daily expenses be if it prepares 250 tapsilog meals in a day? So the independent variable here is your x, which refers to the number of tapsilog. And c of x is the daily expenses for preparing as a particular number of tapsilog. So here we are simply looking for c of 250. So the function, we just simply substitute again. So replace here x by 250, that will give us 18 times 250 plus 170. Multiply this, that will give us 4,500 plus 170. So you will have 4,670, or the food stall's daily expenses is 4,670. Again, do not forget to have the conclusion to answer the question in the problem. Okay, that ends our discussion. For your output, you have to evaluate the following functions. We have here 4 numbers. For application problem, we have question number 1. This is another application problem that you have to answer. And this is application problem number 3. So all these questions will be uploaded in the Google Classroom as a Word file. Kindly visit the Google Classroom for the detailed instruction on how to upload your answers. Thank you and God bless you.